We don't have the box, but we do have the leather jacket, so we're ready to go.
Well, we do have one box.
Back in the year 2000, Microsoft would announce its entry into the console wars with the Xbox, which would change the video game landscape forever. But it's not the announcement that interests me, rather the prototype they used to do it. This massive, solid metal enclosure in the shape of an X with a glowing green jewel at its core was so different from what we've seen in the past. And while the eventual Xbox we got looked nothing like it, the metal prototype left an impression on me, as I'm sure it did many others. It's obvious why these were never mass-produced. Each one cost $18,000 to manufacture back then, or $36,000 today when adjusted for inflation. This was Microsoft's answer to the juggernaut Sony and their soon-to-be-released PlayStation 2. The outrageous design and staggering cost beg the question, could we actually make one of these today? And could we make it better than the original? Well, I think we did. And in this video, I show you how we built a legend. The Xbox prototype.
And I'm the guy who has to figure out how to convince everybody to buy an Xbox.
As we mentioned earlier, the Xbox was announced at this year's Game Developers Conference. But some of you may ask, what exactly is an Xbox?
What is an Xbox? That was the burning question Microsoft had to answer, and quickly. The even bigger challenge? Figuring out how to convince gamers to actually buy one.
Okay, so Gates has made it official, and it is called the Xbox. But in a world with Sega, Nintendo, and the Sony PlayStation, what's going to make this machine stand out?
At the time, Microsoft was seen as a boring software company known mainly for its Windows operating system. So how could they possibly shake that image and go toe-to-toe with the three battle-tested giants of video games?
We had to create a prototype game console that was obviously not going to be the final design of the hardware because we didn't know what Xbox was ultimately going to look like, but at the same time, looked nothing like a PC.
Microsoft needed a way to spark interest for their leap into console gaming. Their answer? Build a prototype so wild, so over the top, and so unlike anything gamers had ever seen, it would be impossible to ignore. This would result in a gigantic 40-pound solid aluminum X with a glowing green jewel burning at its core. Now, I still remember flipping through video game magazines back in the day and seeing this crazy prototype for the first time. And honestly, Microsoft's strategy worked. That wild design left an impression on me and made me believe that Microsoft was serious about taking on these three industry giants. Fast forward 25 years to today, and I decided to take on the challenge of building that legendary prototype down to the smallest detail and improving a few key things along the way. Of course, I couldn't pull this off alone. I teamed up with some of the most talented modders out there who maybe were just as crazy as I was to think we could actually pull this off. Now, building the prototype wasn't going to be easy, or cheap for that matter. I mean, this thing is made out of solid machined aluminum. But if I'm going to do it, I want to do it right. So I gave myself 4 key objectives to guide this whole project. Number 1, I want that solid metal enclosure to be as close to the original prototype as humanly possible. I'm talking the works. An actual fully machined all aluminum shell with a polished front, those iconic cooling fins in the back, and every detail in between, no cutting corners. This thing needs to be indistinguishable from the original both physically and visually. Second, I want this thing to be an actual playable Xbox console. And now I'm sure you're thinking, well, duh, of course this has to be able to play Xbox games, it's an Xbox prototype. But here's the thing, the actual prototype wasn't an Xbox console by any stretch of the imagination. It was a proof of concept, a showpiece to demonstrate the possibilities of the Xbox and get people excited for this new console. In truth, it only represented a fraction of what the production Xbox would ultimately be capable of, but not the one I want to make. We'll need to figure out how to fit all of the original Xbox console hardware into the X-shaped enclosure and still have it work. Third, I want to bring this entire build into the modern era. That's pretty much what I do around here. mod consoles with modern, quality of life upgrades. The Xbox modding community has done amazing work over the years, and I'm excited to pack some of those innovations into this build. We're talking HDMI video out, an SSD for faster loading, and a few more surprises that we'll get into in a bit. And lastly, at number 4, one of the most iconic elements of the prototype is that glowing green jewel at its core. On the original prototype, it appears to be a simple light behind a piece of green plastic, so I think we can do better. Way better. My goal is to make it come alive, make it animated, give it that nuclear reactor vibe, kind of like the iconic Xbox splash screen, to really bring this whole build to the next level. Okay, so those are my goals. They're pretty lofty and at the moment seem downright impossible, but we've got to start somewhere. So strap in and let's kick things off right off the bat with goal number 1, the elephant in the room, that massive machined aluminum shell. So for this, I think I've broken it down to 3 big challenges that we need to address when it comes to recreating the shell. First, getting something this large and this precisely machined out of aluminum is not going to be cheap. The process of machining is very expensive and requires high precision equipment. And for this specific project, we're talking about a massive solid block of aluminum custom cut with tight tolerances into the shape of an X. Back in the late 90s and early 2000s, having something like this fabricated was pretty much out of reach for anyone outside of a major company with deep pockets. And according to the book, Opening the Xbox by Dean Takahashi, it cost $18,000 to build each of these prototypes back in the year 2000. If you add in 25 years of inflation, that comes out to just under $36,000. Basically a brand new car, and there's no way I could personally afford that. But here's the good news. Things have changed quite a bit since the early 2000s, and these processes have become more affordable, but they are still a bit expensive. Thankfully, a company called PCBWay has the ability to machine this shell and is sponsoring this video, which means they'll be covering the cost, so a huge thank you to them for making this project possible, but more on them in a bit. Okay, so getting the shell fabricated, it seems, is in the realm of possibility. But that brings us to the second challenge. Before you can build the shell, you gotta design it. That means full-blown modeling in CAD, or computer-aided design software. Now, I'll be honest, I have zero experience with CAD, so I called my good friend Wesk, an extremely talented 3D designer all the way from Australia, who has a ton of experience designing shells for incredible projects that I've previously covered on this channel. If anyone could turn this vision into a 3-dimensional reality, it was him. Okay, so we have the means to build the shell with services from PCBWay. We have someone to design it, my good friend Wesk, but that leaves us with our third and final challenge. How the heck do we get the precise dimensions of the original prototype that we need in order to model the shell accurately? Getting a rough idea of the exterior design, the shape, proportions, and some of the surface details is easy enough with a simple search online. But that only gets us so far. Plus, another major part of the shell design to consider is the interior, specifically how we're going to arrange all the original Xbox components inside. Figuring out the internal layout design is a whole different challenge in and of itself. So let's tackle each of these 2 hurdles one by one. Let's first start with the actual exterior dimensions. Again, remember my goal is to get this as dimensionally accurate as possible. Ideally, we'd like it to be absolutely perfect. Now, one way we can do this, like I previously mentioned, is to look at photos and videos and try to find reference objects near the prototype that have known dimensions that we can then use to extrapolate the approximate size of the outer shell. Now, in some of these photos and videos, we can actually see a controller. This one, the Sidewinder Gamepad Pro, released by Microsoft in 1999. We know the exact dimensions of this controller thanks to Wesk, who previously modeled it as part of his preservation work. But the keyword here is approximate, and again, I don't want to approximate the dimensions. I want this thing to be spot on. So there's one more approach we can use. After doing some research online, there seems to be 3 actual Xbox prototypes on display to the general public around the world. One in Microsoft HQ in their visitor center, another in London, and one not too far away from me in New York City. If I could get close enough to one of these prototypes, maybe, just maybe, I could get some good measurements. I actually discovered that there was a prototype in New York City completely by accident. I stumbled across a TikTok showing it off, and at the very end, it mentioned it was on display at the Microsoft store on 5th Avenue. The only catch? That video is from way back in 2022, about 3 years ago. So, was it still on display? I wasn't about to make a trip all the way to New York City without first knowing it was still there. So I turned to my amazing Discord community and asked if anyone was nearby that could check. I waited anxiously, and for a while, nothing. Then, a day later, someone finally came through, a member named Lazy CS. Sure enough, the prototype was still there, sitting proudly on the second floor of the Microsoft Store and expected to be there for the foreseeable future. I couldn't believe it, a real Xbox prototype just a few hundred miles away. That settled it. I was heading to New York City. But in the midst of all that excitement, it hit me. Once I got there, how would I measure it? It appears to be in a display case behind glass, and I doubt the employees would allow me to handle such a rare piece of gaming history. So I reached out to Wesk, who again would be the person 3D modeling the prototype, to see if he had any ideas.
I think if you could sneak a tape measure into that museum and measure the case, take as much footage and pictures from as many angles of the case as you can, we can extrapolate that information in 3D space using a Gaussian splat.
So Gaussian splat is a technique that takes photos or video of an object and then stitches them together to create a detailed three-dimensional model. It's similar to photogrammetry, and the results can be incredibly accurate, sometimes down to sub-millimeter precision. We figured this might be our best shot at capturing the true dimensions of the prototype without ever physically touching it. So I packed my bag, bought a train ticket, and headed straight for New York City. Once I got inside the store, I went upstairs, which was completely dedicated to the Xbox. They even had an exhibit showcasing the console's entire history and evolution throughout the years. And at the beginning of it all, the prototype itself. I got right to work snapping a bunch of photos from every angle that I could, and even took several videos. I wanted to make sure I left no angle uncovered. I was there for probably only 30 minutes, hoping I got enough material so that I could give Wesk everything he needed to make an accurate 3D model of the exterior. So, not even being in New York City for more than a couple hours, I began my journey back home to Alexandria, Virginia. And after sifting through all the photos and videos, I consolidated everything and sent it over to Wesk so we can start to do his 3D modeling magic, and well, let's just say the results were pretty incredible. After just a couple hours, Wesk sent me this. Now at first glance, it appears we're looking at one of the photos that I sent him. Only it's not. Wesk was able to generate a 3D model of the entire prototype exhibit simply from the photos that I sent him. Honestly, the Gaussian splat worked flawlessly. With this 3D rendering and the measurements that I took of the display case, Wesk could now make a near perfect model of the Xbox prototype. Things were moving smoothly, but we still had one last hurdle to address for the shell. Figuring out the arrangement of the Xbox components inside the metal shell, and more importantly, how to affix them inside in a sturdy, neat, and organized fashion. For this, I had an idea that would give us enough flexibility and leave us ample wiggle room to refine things down the road even after the shell had been completely fabricated. Basically, we would incorporate these T-shaped fixtures that would allow us to slide a platform in and out of the shell. Each fixture would secure a component like the DVD drive or the motherboard and allow us to easily install or remove them. And most importantly, these platforms, which interface the Xbox components to the shell, would be the only thing we need to make adjustments to ensure everything aligns and fits perfectly inside. So, Wesk began incorporating these T-shaped fixtures in strategic locations inside the shell. These two here are for mounting the motherboard, these are for the DVD drive, this one is for the controller ports, and this one here is for the power supply. At this point, Wesk had a solid vision for how the shell would come together, so I led him to his own devices. But after seeing where we were thinking of putting the power supply, we could actually have a pretty major problem on our hands. So this is the original Xbox power supply. It's a pretty beefy unit that feeds power to every component in the console. But here's the problem. This is an internal style unit with all of its components completely exposed. This is different from an external power supply that's completely insulated. With its dimensions, it could be a bit too large to fit in the area of the shell that we want to place it, which leads me to an even more concerning issue. Since all the high voltage electrical components are exposed, putting that inside of a conductive metal shell, and well, you don't need to be an electrical engineer to see how that could be a problem. So we thought it'd be a smart move to place the power supply outside the console. This would solve both our problems in one go. It makes the internal unit way smaller, and it drops the voltage running through the board to safer levels. And I think we can all agree that's a good thing. And so this brings me to our next member of our motley Xbox crew, Red Herring 32. He's what I'd call our Xbox connoisseur. This guy knows the hardware inside and out and has a serious passion for the Xbox. And as luck would have it, he had already been working on a custom internal USB-C power supply that uses power delivery. Now, without diving too deep, here's the gist of how power delivery works. Essentially, it's a protocol used in power supplies like this one here that basically lets the console requesting the power and the power source handshake and agree on exactly how much power is needed. The power supply then delivers just that amount of power, no more, no less. And since the Xbox only needs 12 and 5 volts, that's way lower than the 120 volts you'd normally be dealing with inside of a stock system. Oh, and did I mention? It's also way smaller than the original. So just like that, we solved both of our size and safety concerns. The only thing left for me to do was to make a custom harness so that we can connect it to the motherboard, and we'd be in business. Making one of these connectors is actually not as complicated as I thought it would be. We simply need to place these specific pins onto a bunch of wires and then crimp them on. Then with all the wires prepped with these connector pins, we simply insert them into an identical Molex connector into the appropriate slot. And once we have the harness completed, we can then solder it to our custom USB-C power board. I actually color-coded the wires so that we don't mix them up. Black is for ground, red is for 5 volts, and yellow is for 12 volts. Then we got these two thin gauge signal wires. They're sort of like messengers that tell the Xbox when to wake up and when to go to sleep when we press the power button. And just like that, our custom USB-C power supply is ready for the prototype build. But behind the scenes, something even bigger was taking shape. By the time we got the power supply all squared away, Wesk had completed modeling the shell, and my goodness, it looks amazing. He also mocked up all the fixtures for the Xbox components thanks in large part to Red Herring 32, who developed precise 3D models of those parts. With pretty much all the 3D models complete, the next step was getting them made. For this, I'll be using a company called PCBWay, who also happens to be sponsoring this entire project. And honestly, none of this would have been possible without them, and I'll show you why here in a second. So to get these built, we need to upload all the files to the PCB website, which is super simple. On the main page here, I'm going to click on the CNC 3D printing option, and then click on Add File. Next, I'm going to drag and drop Wesk's 3D step file here, and this one is for the front half of the Metal X shell. Then I'm going to go ahead and add the quantity that I need, which is just one because I have a feeling this is going to be pretty pricey. And yeah, I haven't even changed any of the settings and we're already at several $1,000s. Yikes. So again, huge thank you to PCBWay. I then went ahead and uploaded all the remaining parts. For the back half of the shell, the part with all the fins as well as the rear panel, I'll be selecting a media blasted finish. This will give us that rough matte look, which should be very similar to the finish on the real prototype. Alright, so we got all the parts uploaded, and this here is the grand total. Yeah, this is pretty pricey. It's way cheaper than the amount Microsoft spent fabricating these, which again was about $36,000, but still not a cheap endeavor by any measure. Then all I had to do is hit submit, and now we wait. In the downtime, I went ahead and started printing all of the interface brackets that Wesk sent over and test fitted them with each of the Xbox components that we'll be mounting inside of the prototype. For the most part, things went together pretty well, but they did need some minor tweaking to get them just perfect. And after a few back and forth iterations between Wesk and I, and many prints later, we were finally in a pretty good place. All the Xbox components at least fit perfectly on the brackets. The only question remaining is how everything will fit once inside of the metal shell, and well, it'll be a few weeks before we can do a first test fit. So while we wait, there is still a mountain of work that needs to get done. In the meantime, PCBWay actually sent over some really cool videos of them machining the shell on their 6-axis mill, which is pretty impressive. Here we can see the back part of the shell being milled down from a huge chunk of aluminum. So we're making great progress here. The power supply is pretty much done, the brackets have been dialed in, and the shell is on its way to being manufactured. Now we can focus on goal number 4, making that glowing green jewel animated. But how on earth are we going to pull that off?
The whole idea was this nuclear reactor almost, trying to hold this energy that's inside that is so intense. That sense of escape and that sense of capability and power is what we try to create with this green portal. And inside there, everything is possible.
Looking at some of the videos and photos of the prototype, the Jewel appears to be a green lens with a light shining through it, illuminating either a DirectX or Xbox logo. And while aesthetically it looks nice as is, I want to take things a step further with an animation that plays the moment the console powers on. Something that encapsulates Horace's vision of a nuclear reactor glowing to life right before your eyes. Now, pretty early in the shell design phase, Wes had identified a small round LCD screen that matches the dimensions of the Jewel, making it the perfect candidate for the project. It has an HDMI input, which was pretty much made to work with something called a Raspberry Pi. Now, the Raspberry Pi needs no introduction. It's basically a cheap, tiny computer that fits in the palm of your hand. This one in particular is called the Raspberry Pi Pico 2, and for those who don't know, this little computer in a way revolutionized the retro video game modding community. Okay, so the basic vision is to have a video start playing as soon as the console is powered on. The only issue is there really isn't any software that exists for the Raspberry Pi Pico that we can leverage to accomplish this goal. And so enters the fourth boy in the band, StuckPixel, who is a talented software developer who has deep knowledge of how the Raspberry Pi Pico works. He designed a custom video format and software tool that essentially allows us to play any animation we want the instant the Xbox is powered on, which will then loop until the console is powered off. Now, I have to say, this was no small feat. The Pico has very limited horsepower, so he had to get clever using the built-in hardware features to compress the video data and juggling multiple high-speed data channels so that one frame was being loaded while the other was playing. And through sheer will and a few clever tricks, StuckPixel was able to push the Pico to the limit and get us a smooth, looping video animation the moment it's powered on. Wes made a couple cool looping videos that we could choose from, but I think this Xbox logo with the atom spinning around it looks really nice and fits with the whole reactor theme that Horace alluded to. Now, to get this whole thing to work, I did have to slightly modify the Pico with something called a DVI sock, which gives it HDMI video out capabilities. I also had to modify the LCD so that it turns on when the console turns on. If I didn't do this modification, the LCD would be on the entire time, and that's not something we wanted. And I have to say, with it all put together and running, it looks absolutely stunning, and I really just can't wait to see how this looks inside of the finished prototype. Now, as we wrapped up the Jewel assembly, an email popped up in my inbox from DHL. Looks like a pretty big package just arrived. The metal shell had finally arrived at my local DHL hub, so I didn't waste any time, hopped in my car, and headed over to Washington, D.C. Alright, so we're heading to Washington, D.C. to the DHL hub there to pick up the package. It's been about a month since it was shipped. It got shipped back to PCBWay, and then it got shipped back to the US, so it's been a long time. I've been talking to DHL pretty much every day for the past 2 weeks to try and get it cleared through customs, but we are finally heading there to pick it up. So yeah, just to elaborate, as many of you probably know, getting things imported into the US lately has been kind of a nightmare, and this massive metal shell was obviously no exception. It got stuck in customs while I was busy filling out paperwork, and out of the blue, for some reason, still not sure why, DHL actually shipped it back to PCBWay. I pretty much went into full panic mode. I didn't think I'd ever get my hands on the metal shell, and this project would be stopped dead in its tracks. After a flurry of emails between me, PCBWay, and DHL, we managed to intercept the package in Hong Kong and get it rerouted back to the US. All in all, the process took several more weeks, and I was seriously stressed the entire time. But thankfully, things worked out and it arrived in the US. Now, my only hope is that it arrived in one piece, unscathed from all that additional travel. But I guess we'll have to wait and see. After showing all the paperwork, they finally brought out a wooden crate, and I don't know if you can tell, but I'm pretty excited that it was finally in my hands after all this time. Now, I just had to make sure to carefully transport it back to the studio so we can finally unbox this thing and see how it came out. Back at the studio, I didn't hesitate to tear into the package, and I think it's pretty cool that it was shipped in a wooden crate rather than a cardboard box. It was definitely packaged very nicely, and it thankfully arrived in one piece. Now, I have to say, right off the bat, these came out absolutely incredible. They look just like the original prototype. The finish on this, we got this media blasted, so it has that perfect matte finish, just like the original prototype. However, you'll notice the front does not have that mirror finish that's very characteristic and emblematic of the original prototype. You'll see it kind of has more of this sort of brushed finish. So initially what we wanted to do is we wanted to get this chrome plated at PCBWay. That is a service that they provide, but unfortunately due to the size and weight of this, they were unable to do it, which is not a big deal. So we're gonna basically have to rely on me trying to do it myself. Now I did a ton of research on YouTube trying to figure out how to polish aluminum. There's a ton of different methods. I think I found one that should work pretty well. So I'm gonna go ahead and give that a shot and hopefully I can pull it off.
That box took 2 weeks to carve and 1 week to polish. Drew and I just after work, get a can of kerosene, get a rag, and just keep buffing it. Rub, rub, rub until that thing was polished.
While it took the Microsoft team a full week to polish the metal shell with nothing more than kerosene and a rag, I only had a couple of days while visiting my parents. They had the space that I lacked in my small apartment, so the quicker I could get it done, the better. Getting raw aluminum to a mirror finish is brutal work, but if my method pays off, it should cut the time way down. The process that I'll be using starts with sanding, starting with a 600 grit and working all the way up to 5000 grit before finishing it off with a metal polishing compound. The rule here is simple. The lower grit sandpaper is rougher and removes more material, while the higher grit is smoother and refines the surface. You'll also see that I use something called Allumicut in between sanding. This acts as a lubricant to help the overall process. After each sanding pass, I'll wipe it down and then move on to the next grit, repeating until I've worked all the way up to 5000 grit sandpaper. And once that's done, it's time for the polish. I'm using one that is specifically designed for aluminum. All I do is rub it in with a paper towel and then buff it out with a foam polishing pad on my drill. And the results? A smooth, reflective surface that looks pretty good. It's by no means perfect, but I'm really happy with the finished product. I tested this process on the underside first to make sure I liked the finish, and once I was happy, I went ahead and polished the rest of the shell. It was definitely a tough and time-consuming job, which took several grueling hours to finish, but the payoff was worth it. Once done, I gave the shell a good washing with a garden hose and some car cleaning supplies to get it ready for an initial test fit to see if I can actually cram all of the Xbox components inside. At this point, my back was killing me. However, I honestly couldn't be happier with the results. So back at the studio, let's start to put this thing together for the first time. But I can't help but think, will it come together smoothly, or will we need to go back to the drawing board? I'm going to go ahead and start with a mock-up of everything inside the shell, since I'm sure we'll need to make some adjustments to those brackets, or who knows, maybe even spot a design issue that we'll need to address. I went ahead and sourced all the other needed hardware like screws, cable extensions, as well as miscellaneous parts like cooling fans. It was now or never, so hopefully all that planning and design work will finally pay off. I get things started by first placing all the Xbox components onto their respective 3D printed brackets. I already tested these, so they mount perfectly without issue. Here you can see the Xbox motherboard, which has already been modified with an HDMI kit. I covered this specific modification in another video of mine if you want more details about it. Next, we have the DVD drive, which slides into its bracket and is then secured with a couple screws, many of which are reused from our donor Xbox console. Now here, I'm using a SATA SSD hard drive. We actually had to use a 2.5-inch drive here since the standard 3.5-inch ones would actually not fit into the aluminum shell. So we decided to go ahead and use an SSD, which is going to be quieter and run a little bit cooler. The SSD itself is mounted on top of the DVD drive bracket, which should help save some space when installed inside the shell. So now we can go ahead and start to slide in all the components into the rear housing, which is where all those T-shaped mounting points we discussed are located. One of the first things that I noticed is that they don't slide in super smoothly, so we may need to make some slight adjustments to the bracket design. Now, I was a bit nervous at putting in the DVD drive since the distance between it and the heat sinks on the motherboard is extremely tight, but my goodness, it fits like a glove, which is fantastic. Now, unsurprisingly, even though the power supply is much smaller, it is still a bit of a tighter fit than I expected. I think it was mostly due to the orientation of the thick gauge wire that I put on there, but between the heatsink and the shell enclosure, things are just a bit cramped. Okay, so I'm hooking up some of the controller ports and I was able to source some extensions, which are these black cables here that give me more than enough length to run the connector to the proper location on the motherboard. I actually really like how the rear part of the metal shell is open on both sides. It makes wiring everything together surprisingly easy since I get access from both directions. Now, as a temporary solution, I am connecting the front panel PCB, which has the power and eject buttons, directly to the motherboard. In the final version, I will run those wires to the rear panel for easy access. And this right here is the IDE to SATA adapter. As you probably know, the original Xbox used an IDE hard drive, but we're using a more modern SATA SSD. This little adapter makes the SSD fully compatible with the Xbox hardware, and it's actually a pretty common mod for the console. Here I've got an 80-pin IDE cable that connects both the SATA adapter as well as the DVD drive. I did have to fold it like origami to get the orientation right for both connectors, and the other end of the cable then plugs directly into the motherboard. Now here I'm hooking the SATA adapter to the power supply, which has a dedicated connector for the hard drive, which is a really nice touch that Red Herring 32 built into the power supply. The other end goes into the SATA adapter, which is actually covered by the IDE cable. I should have definitely hooked up the power first before I did the IDE cable. Anyway, it looks like almost everything is hooked up. Next, I turn my attention to the rear panel. And unfortunately, one of the things we forgot to design in were openings for both the power and eject buttons. So I went ahead and drilled a couple openings for some push buttons that I purchased, just again to make sure everything clears once it's fully installed. I put them at each corner with the eject button closest to the DVD tray opening and the power button on the opposite side. I then went ahead and installed the buttons, and they do extend out quite a bit, so hopefully they don't get caught up on anything inside the case. Next, I grabbed the two cooling fans. I'm using two 60mm ones from Nacho, which should hopefully do the trick and provide enough airflow. I secured them using the recommended screws from Wesk, and they bolted in perfectly. And then to power them both at the same time, I purchased this cable adapter which combines the two fans into a single connector, which should then fit into the stock connector on the motherboard for the original fan. And giving it a quick test, we can see that they both spin up, which is awesome. So far, everything is really coming together pretty smoothly. Now, let's see if we can attach the rear panel to the shell. And this is where I actually noticed our first problem. I was unable to fully seat the rear panel flush to the shell, which means I won't be able to close it. Upon closer inspection, it seems that the bottom part of this fan is hitting the DVD drive power connector on the motherboard. This should be a pretty easy fix. I just need to trim the bottom part of the fan as well as the screw. After a bit of hacking with some flush cutters on the fan and cutting the screw down to size with my Dremel, I put the fan back in and the rear panel fit like a glove. Thank goodness. It seems like that was really the only issue I had. But now there's one thing left to do. Hook it up to the TV to see if the thing actually works like an Xbox console. Making sure everything is connected properly and double checking all the components, I hit the power button. And after a brief pause that felt like ages, I got that glorious Xbox reactor in full high definition. We are officially in business, and this thing is actually working. I can't believe it. After months of working and waiting, I can finally see a light at the end of the tunnel. With the primary function of the console working and everything appearing to fit, Wesk made those few adjustments to the brackets to make them fit just a bit better, and we decided to have them all professionally printed and painted green at PCBWay. This time we're using a sintered nylon material, and the results are absolutely incredible, as you can see here, way better than my FDM 3D printer. Now, like I alluded to earlier, we also wanted to update the rear panel, and here it is. One late-breaking design change were these openings for an extra button and the USB port. These will allow us to connect to the Raspberry Pi and change that looping video for the Jewel without having to open the console. I'll show you how we're going to wire these up in a second. And of course, we included openings for both the eject and power buttons, along with some nice engraved symbols for each, and I think it just came out amazing. Again, major kudos to Wesk for these incredible designs. Alright, let's get this thing finally assembled for the last time. After mounting all the Xbox components to the newly printed brackets, I actually went ahead and started making wiring harnesses for all the buttons and various items that will need power or connect to the rear panel. I want this to be as clean of a build as possible, as well as easy to service in case I ever need to make repairs down the road. After making the wiring harness for the power and eject buttons and mounting them to the rear panel, I soldered the other end to the power and eject controller PCB, which will allow me to do those operations when I press those buttons. And here it is all assembled. I then attached the fans to the rear panel just like before, and this here is the USB micro port that will give us access to the Raspberry Pi from the outside so we can easily change the Joule animation. It simply mounts with a couple of screws. And this here is the push button which will allow us to put the Raspberry Pi into USB mass storage mode so that we can go ahead and drag and drop the animation files onto the Pico. I'm soldering the opposite end of the wire harness for the button to a JST connector so that I can easily connect and disconnect it from the Raspberry Pi. This will again make it easier to assemble and disassemble the console if I ever need to in the future. And of course, I did the same thing for the Raspberry Pi itself. I made a custom harness with a JST connector for both powering it, as you can see here with the red wire, and on the other side tapping into the boot cell button by soldering this yellow wire to test point 6. And taking a look at the power supply, I also made a few additions from the initial assembly. These 3 wires here will connect to various parts in the Xbox. This one is for powering the Raspberry Pi, this is for powering the LCD, and this last one is for sending a signal to the LCD to turn on its backlight when the console is also switched on. Anyway, everything is prepped to be installed, so let's put it all together. I'll start by sliding in all the main components into the rear shell housing, then I'll run the cabling to both power and connect the SSD and DVD drive to the motherboard. All the cabling gives me plenty of length to comfortably make all these connections. And thankfully, I don't really need to worry too much about cable management since I do have ample room inside of the metal shell, but I do try to keep it as tidy as I can. Now for one of the more exciting parts of the build, installing the LCD screen into the front metal housing. Honestly, can't wait to see how it looks when it's up and running. It's mounted extremely securely with quite a few screws, so it definitely won't be going anywhere. Alright, now I can basically combine the front and the back half of the case. I'll start by connecting the Raspberry Pi and LCD to the power supply, followed by the connectors for the exterior boot cell button and the LCD power signal. The JST connectors that I installed on all of these wire harnesses make doing all these connections a breeze. I then connected the power eject PCB to the motherboard and the USB extension to the Raspberry Pi. Okay, all the connections have been made. I can now very carefully bring the 2 halves together, making sure none of the wires are getting pinched in the process. And to secure the 2 halves together, I'm using 4 massive 5cm long M6 bolts, which I had to fasten using the screwdriver with a pretty long extension because they're pretty recessed into the shell. But after getting those torqued down, all I had to do was mount the rear panel. After managing some of the wiring and getting it flush to the shell, I fastened the last 4 screws to button it all up. And that, ladies and gentlemen, is the Xbox prototype fully assembled. But the million-dollar question is, will it function like I envisioned? Now, after months of designing, machine work, polishing, wiring, and reworking every last detail, it all came down to this single moment. Would the prototype actually power on? Would that glowing Joule ignite like the nuclear reactor we imagined? And would it play games? Or would all of our work end here in failure? This was the ultimate test, the moment of truth. Oh my goodness, I can't believe it, it's actually working. This is the part where I jump up on stage and do a full-on Windows 95 dance, but I think I'll leave that to Bill and Steve. We got an image on screen, the Joule came to life, the fans are spinning around back, and for the first time ever, this massive aluminum prototype isn't just a showpiece, it's a fully working Xbox. Months of planning, late nights, and some small setbacks had all led to this moment, and seeing it actually power on for the first time feels surreal. The original prototype was never meant to play games, but ours does. And in this instant, that dream of bringing that legendary prototype to life became a reality. So with that amazing news, let's take a look around this incredible build and see what it can do, and what it's all about. At its core, it operates just like any other Xbox, because that's exactly what it is, a factory system repackaged into this one-of-a-kind shell. This button powers on the console, this ejects the DVD tray, the controllers go here, and the video output and Ethernet ports are here. Now, where we get into some of the differences from the stock Xbox console is with this HDMI port. On the original system, there's a proprietary AV port on the back that outputs analog video in either composite or component depending on the cables you use. This one, however, is modded with a fantastic internal HDMI kit, giving us the absolute best pure digital video output possible. Additionally, the motherboard has a mod chip installed that allows me to run a custom dashboard, meaning I could load games right from the SSD, control the fan speed, and do many other very cool things. So essentially, that means I can load a game either from the internal SSD or from the DVD drive, making this a pretty versatile unit. Another modern quality of life upgrade is the USB-C power supply. The entire unit is powered with this tiny PD-PSU from Anker using only this USB-C cable. I think this is such a cool upgrade, and the fact that we're able to go from this to this is pretty remarkable. And when it comes to the jewel in the front, well, I think we can all agree it looks absolutely fantastic. It really just brings the whole build together and is a huge improvement over the original. Now, I can actually change the animation to whatever I want. All I need to do is press and hold this button while connecting the prototype Xbox to the computer through this micro USB port we integrated into the rear panel. It'll show up as a mass storage device on my computer, and then all I need to do is drag and drop the custom UF2 file, which is essentially in this case a custom video, onto the Raspberry Pi, and then it'll auto eject and show the new video on the Jewel. It's really just that simple. We made a few different looping animations, like these shining Xbox logos, a DirectX one, which is an homage to the original, and even this guilty spark guy from Halo. Really, you can just get super creative and put anything you want there. But again, I think the best animation is this one, with the atoms revolving around the Xbox logo. It just really brings the whole build together. And when it comes to gaming, well, it just works. Sure, this may not be the most practical Xbox in the world with its massive size and hefty weight, but let's be honest, it's definitely the coolest. This beast comes in at nearly 40 pounds, which is insane. But despite that, I think it's safe to say we nailed all 4 of our goals that we set out to accomplish. The shell design is spot on to the original, it plays real physical Xbox games, is packed with modern quality of life upgrades like the HDMI mod as well as the SSD, and yes, the Jewel is fully animated and looks amazing. So now that I have this giant hunk of aluminum, what am I going to do with it? Honestly, one of my biggest goals is to share it with all of you. I just got back from Retro World Expo, which was a blast as always, and I definitely plan to bring the prototype to the expo next year. There's just something really special about experiencing this in person rather than through a YouTube video. So I'd love to give you a chance to see it up close and even play games on it. Let me know down in the comments which retro conventions you'd like me to visit, and you may just see me and the prototype there next year. Now, traveling with something this heavy and this oddly shaped isn't exactly easy. I just can't throw it into a carry-on. So I worked with the amazing folks over at My Case Builder to design a custom Pelican case with a precision cut foam insert, and I think it came out absolutely incredible. Their web-based design software made creating this custom foam insert an absolute breeze. Microsoft actually had to make similar cases for transporting their prototypes to different trade shows, so I wanted to do something similar. And I'll actually be putting this case to the test really soon for a trip out to Redmond, Washington. And trust me, you're not going to want to miss what happens there, so make sure you're subscribed to the channel. I have to give a huge thanks to My Case Builder for hooking me up with this custom Pelican case. If you ever need a solid way to protect your own gear, definitely check them out. I'll have their store linked down below. Now, before we wrap things up, I gotta give some much deserved shout outs. First, to the dream team that made this whole thing possible. Wesk, Red Herring 32, and Stuck Pixel. These guys took this crazy idea and actually turned it into a reality. I also gotta give a massive thank you to PCBWay for sponsoring this entire project. Given the massive cost and the incredibly precise machine work involved, they played an absolute crucial part in bringing this project to life. I also need to thank my Patreon supporters who helped fund the other miscellaneous costs of making this video, from all the travel, extra parts, and all the unexpected expenses along the way. But most importantly, to you, the viewer. You're the reason I get to make videos like this, and none of it would be possible without your support. I know it sounds cliche, but I honestly believe this community is one of the best on the internet, and I'm so grateful to have you here with me every single week. Oh, and one last thing. We made these limited edition Xbox prototype t-shirts which showcase the blueprints of the design that Wesk made for this project. They come in this appropriately colored lime green as well as others, so definitely check them out in my store linked down below. So again, thank you all for watching, and I'll catch you in the next one.